Welcome all to our webinar, How to Start Easy with CQRS. In several minutes, we'll start, maybe even earlier. We have guests from, if I say from all over the world, from Serbia as well. It's so nice to see that people were reacting very, very nice to this topic. So maybe I would use this opportunity in this short window to introduce myself. My name is Bojana and I am community manager here at InterVenture. And welcome to our new tech talk, this time with our dear colleague, experienced .NET engineer and director of engineering at Aspen Dental, Marko Lazic. And we are especially proud of the fact that Marko has been with us for almost 9 years now. So it means from the very beginning of InterVenture's journey. So it's a huge privilege, if I must say. And so use this unique opportunity to learn more about how to start easy with CQRS and participate in our Q&A session after the lecture. And for those of you who are first time with us, I'll just say that InterVenture is all about assembling first-class engineering teams who build amazing software solutions and covering various industries such as media, telco, insurance, fintech, mobile payments, e-commerce, etc. And we're working on product development of some of the great tech solutions worldwide. So if you would love to know more about some career opportunities with us, I'll share some useful link in chat a bit later. And maybe with no further delay, I would like to give Marko a chance to start the talk, actually. Enjoy and see you in a bit.
Thank you very much. Yeah, so I mean, you already said a bunch of things about me. Let me just add, yeah, of course I'm pretty long in software development. I've been a .NET engineer for quite a while. I've been in multiple other technology stacks as well. I've been working with several big companies, both in Europe and US. Lately in US, in Aspen Dental, as you mentioned. Currently, I'm working as director of engineering and leading a couple of teams. Cool. So yeah, as I said, I've been in the industry quite long and have a variety of technical and architectural experience, and this talk is mostly coming from that experience as well. So perhaps we can start with the overview of what we'll be talking here. So CQRS is the kind of thing that a lot of developers are struggling with. Developers might have problem with choosing exact technologies to implement this, and there might be also cases where developers are struggling with the solutions for reliability. So in order to actually go with this, we'll go through several points. So we're going to go about what CQRS and what it isn't actually, and we'll also try to understand its benefit and where it's actually applicable. This is a really important question of where it's actually applicable, because not all places where you can put CQRS are good places to put CQRS, and that might be the usual error. We're going to be talking about design. We're going to be going through the details of an example with .NET services, with Google Firestore NoSQL storage and Google Cloud Functions. And after that, we're going to talk about where to actually go from this basic example. So first, let's try and summarize the core of what CQRS is. So CQRS is basically a command query responsibility segregation. So with CQRS, the main focus would be about solving performance problems, and those performance problems would be specifically the ones that are produced by clashing read and write stacks on some resources. So this might sound abstract, but in an example, you probably all had cases where you have deadlocks in your database levels, and these are produced by different queries clashing and making locks on databases. This is usually by queries, basically asking for fresh data or consistent data, and basically putting the load on the right side of writing to storage. There's also cases where you're using other resources, like resources that your services are directly depending upon, and you want to scale these resources, and you're not able to do that if reading and writing stacks are coupled together. So as I said, this separation might happen on different levels, on data store levels, like separate databases or separate views or something like that, or you might also do the separation on service levels, where you would actually deploy two separate services applications that you would then be able to scale separately and basically add more resources on the side that you need more reading and writing. Unless you're seeing the problems in performance related to resource sharing, you might not want to implement this. So let's go through what CQRS isn't actually, but what it's actually usually coupled with in different talks and articles. One of them is event sourcing. Event sourcing is a technology that kind of tracks changes as deltas and never loses state for certain components, but it's not actually directly tied to CQRS. It's something that can be combined with it, and usually is. There might be cases where people want to implement domain-driven development on the writing side, but once again, it's not something that is directly coupled with CQRS. Same with messaging services. It is one of the implementations of how you would want to do it, but not necessarily needed. And actually, in my example, we're not using messaging explicitly. And there's also cases where some might advocate for specific technology for storage or for communication, but once again, we don't need to do that. So just to recap, CQRS is all about separating writing and reading stacks. It's not tied to specific technologies. I'm reiterating this because it's actually something that puts a lot of load on anyone who's new into CQRS, and I'd like to give you a chance not to feel that load. So let's go in details of where it's actually applicable. So systems with lots of requests. So where is it actually applicable? It's about systems with lots of requests, systems that have multiple times more writes, more reads than writes, and there are resources that are shared between reading and writing stacks that are becoming bottlenecks, and basically one stack would block another or multiple threads of writing stacks would block each other. These are the cases where we want to implement this. Why do we actually do it? We want to implement CQRS when we want to solve performance issues that are specifically produced by deadlocks on resources like database or resources like application server that is running your services. We want to be able to scale independently either services or database, either application service layer or database service layer to adjust performance. Some downsides that are pretty common and might explode if you over implement it are increased complexity. One point that is really important is that since we're separating writing and reading stacks, there is some inherent latency between data availability on reading side compared to the writing side. It's basically not there instantaneously. And it also pushes for some complexity in the front-end application. Because front-end applications need to understand that reading and writing are not going to happen in one request. So let's go towards implementation. So some basic design elements that we want to go through. The main elements that we want to recognize in any CQRS design is the branch through which we are introducing changes. That in this case, let's say we have a service and a storage for it. We also have the reading branch that might also contain a service or an endpoint and a separate storage. And there's a mapping element that's doing the actual mapping between writing storage and reading storage. And once again, there's this inherent latency that we're talking, and it's related to this mapping element. Couple of notes about the actual when we're talking about design. This design is pretty abstract. It's not showing technological boundaries, and it's not indicating how you should implement this. That's we're going to go through a more detailed diagram later on when we go towards the example. And once again, mapping takes time. When client queries the data in the bottom part, it might not be immediately available, although the actual command from the client side point of view already finished. So let's go into details of what writing changes branch is actually going to do. Writing changes branch should really focus on basically writing the changes to the system, data that you want to persist in the system, and doing it in a quality way. So what I mean by that is checking authorization and validating all the data rules. Basically, is data that's incoming valid, and is it consistent with the rest of the system? Validate all the domain rules there, and the response that we return when client writes the changes, it's not actually going to indicate the result of these changes. It's just going to indicate that the request is accepted. That's the important distinction to any implementation where you might synchronously return results. In the reading branch, we want to focus on reading the state of the system in the form that's best suited for specific scenario of reading. We of course want to check authorization for specific objects, but what's really important is that any data model in the reading branch are specific to that scenario that we're looking into. We're not gonna try and support different needs of the client by same API. We're going to have different APIs, we're going to have different models, and again, these models have no tie to the original writing models. We don't want to transform the data that we're reading, we just want to return the data as it is persisted in the query side storage. Those are important important distinctions. So no transformation or any changes whatsoever. And the last part, the mapping part, once again, that's the part that needs to exist to map the changes introduced into the data that we're reading in the end. Mapping needs to understand that change happened. So there needs to be a mechanism that's doing the notification part. There needs to be a part that's actually mapping the change into the specific reading model and writing the new value. There are questions about the delay that mapping introduces and reliability that mapping mapping element has, and that's what we'll go into more details later. So I understand that up to now it was pretty abstract, so we're definitely going to dive into an example here. So let's say we want to model a system to support banking transactions like deposits and withdrawals from an ATM. And we want to, on a separate range, we want to be able to query the balance on our phones. So a bunch of us has financing banking applications and can easily query the balance. And it's actually mostly queried in a subtle way when you get text message notification, or you get anytime you open the app, it's always queried. So that's the case where the actual changes on your account are way more rare than actually querying. So we want to support that on an ATM you can deposit some money, and we're going to treat it as a transaction that has a positive amount. We want to support withdrawals, and we're going to treat transactions with amount less than 0 as withdrawals. And on the reading side, we want to be able to ask for balance for my account, and we want to get the actual balance, and we want to get the timestamp of the last change. This is something that kind of subtle. We definitely want to write this timestamp when we write transactions, right? So let's go into details of how we would actually implement this. So as a service layer that's going to be accessible with RESTful endpoints, I'm going to have two services. One that I call transaction service. That's the one that's going to accept transactions from an ATM, and it's going to validate these transactions, and it's going to write these transactions in its own storage. And on the balance side, we're going to have a balance service that's going to expose an endpoint for getting the balance, and we want to read the actual balance from its own storage again. So what I said with the HTTP endpoints, RESTful endpoints. These are basically how I imagine it. So let's say we have a post on /account ID /transactions. So that's posting new transactions. And on the other side, I want to have like get /account ID balance. Pretty standard, right? On the storage level, I want to persist transactions in a transaction collection that's basically implemented with Firestore NoSQL. And I also want to read balance from another collection that's going to be called balances. Once again, this is an example with this specific technology. This might be anything else you prefer. And we're also going to go through any implications of choices later. And I want to have the actual mapping element that each time I persist a transaction in the initial storage, in the transaction storage, I want to somehow trigger this mapping element that's going to write the new balance, update the balance in the storage here. This balance mapping function, I'm going to implement it as a cloud function in Google Cloud. And it's going to have a Firestore audit trigger. So anytime I change, anytime I write a transaction in this storage, is going to be automatically triggered. This implementation is specific to Google Cloud, but once again, we'll go through any variations in how you might want to do it with other technology. And how I'm going to actually test it. These two services are going to expose a Swagger that's, if not all are familiar, that's a way of documenting your RESTful APIs and exposing a convenient client for development time. And it's ideal for testing like this. So let's go into code. I'm going to share my other screen. So although the actual implementation here is .NET, it's fairly simple. So I'm pretty sure that each one of you, whatever your background is, can easily follow along. So most of this is basically plumbing stuff. Except for the Swagger UI I mentioned earlier. The actual focus of what we want to explore is behind this one. So here I'm registering a specific endpoint that I'm going to listen to. So that's the one I mentioned earlier in the previous slide, where I said that I want to accept posts on /account ID transactions. So this is going to be invoked when we call from Swagger UI, when we call and submit a new transaction. I want to do some validation. That's what I mentioned earlier about what would be the responsibilities of the writing branch. And after I finish these validations, I want to actually persist this, and I want to return an acceptable HTTP status for this one. I'm returning 202, that's accepted, and that kind of perfectly describes what I did here. I just accepted the request. And to dive a bit deeper in this save transaction method, I'm accessing a collection. Firestore collection. I'm creating a document with a new ID, and I'm setting this document to something that contains my data here. So I'm saving the ID, I'm saving the account ID for which the transaction is happening, I'm saving the amount, and I'm saving the timestamp, just to be sure that we know when this transaction happened. So this is all pretty pretty self-explanatory. I'm going to jump into the balance side where we're actually querying this. Once again, the service itself is fairly simple. We want to focus on what we do in the balance endpoint. And here you would notice that I'm not trying to validate anything here. Of course, the authorization I mentioned, that's not in the example, just for keeping it simpler. So here I'm just querying the balance. And querying the balance actually means that I'm accessing collection that's called balances. So just to remind you, in transaction side, I'm accessing the transactions collection, and in balancing side, I'm accessing balances collection. So these are two different collections. I'm not reading the same storage, and I'm just returning some object, and it's going to have amount, and it's going to have a timestamp. Just to quickly go through the mapping element. So mapping element is specific now to Google Cloud infrastructure, and what will be the focus here to just for you to more easily understand. Handle async method is something that's automatically invoked with the Google Cloud framework under which this function is running. Document event data is basically an object that describes what actually changed in the original transactions collection. So this kind of contains data about the original transaction. So I want to read this data, and I'm doing it behind this method get fields. I'm getting the actual account, so that would be some identifier for my account. I'm getting the amount that happened, and I'm getting the timestamp when the transaction happened. I'm accessing the collection balances, and I'm writing this new balance into this collection. So just to step into this write new balance, I'm calling set async to actually write the new version of the balance. That's an important thing. So in terms of responsibility, transaction service is persisting into transaction collection. A balance service is reading from balances collection, and the actual writing into balances collection is happening in the mapping element. Cool. By the way, I deployed these services as containers in my local Kubernetes cluster, and I'm just going to start Rancher desktop because that's how I manage my Kubernetes cluster in the backend. And I'm using Google Cloud Collections and mapping function that's actually deployed in my personal Google Cloud. So let me share the other screen because we want to go back to the browser. Yeah, so let me now share my other screen, and let's see how it all looks when being demoed. What I've just shown you as in code, I'm going to share my browser where we can access
the deployed version of these services and of the actual mapper that's doing the mapping between written data and the one that's being read. So what you now can see on the screen is changes service. That's the one where we're posting transactions. And you can see what you're seeing here is Swagger UI, the way to describe and explore RESTful APIs. And you can see that I exposed post on /transactions. I'm going to try it out now. And let's say my account ID is just Marko for being able to more easily debug when we look at the actual data. And let's say I just got my paycheck and I'm doing a deposit on the ATM with the amount that's positive 1,000. I'm going to click execute. And that's actually targeting my deployed version of the transaction service, and it's posting this transaction. And you can see that the actual server response I got is a 202 that's accepted. And it doesn't have a body because it's not actually needed. And this is a positive response. It means that my transaction service accept this transaction. So now let's check the actual transactions collection that I mentioned earlier. And we're going to step into another tab where I have opened my Firestore in my Google Cloud. And you can see that I have these two collections. One that's called transactions, that's where we're posting the data. And you can see there is one transaction here that I just posted. When we actually look at the details of this object, this document, it says account ID Marko, it says amount 1,000. That's what I just posted. It's got a timestamp and the unique ID. Let's step into balances collection, and you can see there is a document that's just been created with the ID Marko for my account ID, and it shows the amount 1,000. Timestamp is the exact one as in the previous document. That's actually the last transaction. So let's check if our querying side is actually going to read this balances collection, and that's where we step into the other Swagger UI for querying service or balance service. And you see that I here have exposed a get on /account ID balance. So I need to supply my account ID. Then I'm going to put the same one as in previous one, Marko, and I'm going to click execute. And you can see that server responded with 200 OK and actually returned a body that's stating that my current balance is 1,000, which is correct, and timestamp is the one that we previously saw in the balances collection. Let's repeat this a few times. So I'm going to step back on the transaction side, and I'm going to post, let's say, another deposit. Let's say I got a bonus for making a good webinar for CQRS, and I just got 200 more of some money. And I'm going to click execute, and you can see that server side responded with 202 again, says accepted. Let's quickly step into our transactions collection. Now you can see that there is another one. I've created a filter that's sorting these by timestamp. So the lower one is the newest one, and you can see that there's 200 more here. And now, of course, we're expecting a balance of 1,200, and we can see that the actual balance is updated here. and let's see if it's actually read on the service side. I'm still gonna keep this Marko because I want the same balance. You can see the previous balance here, and when I click execute, you can see that now it's updated. Says 1,200. Let's try something more. Let's say I need some cash to perform some Christmas shopping or whatever, and let's say I'm putting -300. That should be considered as a withdrawal, and the balance should be reduced by this amount. So let me click execute. I got 202. Okay, 202 accepted. Let's step into Firestore. We can see there's a third transaction here with -300 amount, and let's quickly step into the querying side, the balance one. You can see that here's the old one, 1,200. When I click execute, we're expecting 900, and that's what we show here. So you can see that the changes are propagated from the reading side through service, through writing side, and its own persistence that we have in transaction collection being mapped to balances collection, and then we can read it through querying side balancers. And let me just quickly show you how it actually looks on the mapper side. So this is the page that corresponds to what I have deployed as a transaction to balance mapper, and in the logs, we'll try and see if it shows more transactions being processed. So you can see that here we have the first initial transaction where I deposited 1,000, right, for account Marko. Then we have again a new transaction event where we have the amount 200 again for the account ID Marko, and here's the third one where we have a negative amount of -300 for the account Marko. So this is what actually logs look like for a cloud function. You can easily, if you put the logging in place correctly, you can easily debug anything you need from this one. And that's for the demo part.
So we're going to talk about next steps on how we want to proceed after implementing this simple solution, or I don't know, skipping this simple solution, and what would be the next steps if you want next or alternative steps, if you will. So the first and probably the easiest one would be choosing the exact API service stack. So in my case, I use .NET in containers, but you might use Java or Python or Go or whatever. Basically, the choice would be primarily driven by what you're already using in your team or in your project, or what you have expertise for. And there's some connection to choosing the part about the meeting events in one of the scenarios, but mostly this would be driven by what you're already doing. So let me go about choosing the exact technologies for writing and reading, so persistent technologies. Once again, in my case, I used Firestore NoSQL collections that are available in Google Cloud. So if you would be doing anything deployed in VMs or in Kubernetes in Google Cloud, you would be able to use these Firestore collections easily. So for changes side, this side, people often choose SQL because SQL is by its core design, it's more oriented on the on keeping data quality and data integrity in check. So, of course, in my example, I would be doing these validations from the service level, but in SQL, you might want to delegate some of this validation to the actual SQL level. So you might want to persist something and then basically let it explode if it doesn't meet some validation standards. So that's one option that's usually chosen. For the query side, you want to go with something that offers performance. Right, because it's not the same instance of storage technology, you might want to choose different technology. So that's one thing that's really important. Let's say you're going with SQL on the changes side, and you don't want to step out of SQL world. You might want to implement the query side with views that are persisted. So basically, in that scenario, the actual mapping would be happening by the SQL server itself. Probably better and often chosen version is going with NoSQL because it generally offers way more performance. Reads are where NoSQL really excels. And you can also use it in combination with in-memory caching. So the actual direct connection here, it might not be as direct. You might want to use memory caching inside of balance service or in between balance storage and balance service and further increase performance on reads. For choosing the exact technology for mapping, that's probably the hardest choice in all of these. Mostly it is chosen in connection with what you're currently using as a storage. So once again, just to remind you, you want to have notification element, you want to have mapping element and writing element, all part of mapping. So for notifying changes, you want to choose something that's tied to this storage and that's compatible with this storage and that can be triggered, that can produce a notification or an event, if you will, when changes occur here. In my case, cloud functions can be triggered by Firestore audit events. And actually underneath it's using a pub sub and an event, so it's pretty reliable. But if you want to go with SQL, you might want to use some CDC, capture data change technologies to actually be triggered once you write something. So one example is the Bezium. So it can listen to your changes in database and it can produce events going out to Kafka. And balance mapping element would be triggered on those Kafka events, and that's where the writing would happen. How you actually implement the balance mapping in the case of events, if it's going to be a cloud function or a separate application that only does that processing, that's up to you. Really important element here is reliability. So we definitely don't want to lose these notifications. And on the other side, when we get the notification, we want to either process that notification and write here or completely reject notification in hope that we can repeat the notification later. So these elements might be the touchiest, the most fragile elements in CQRS implementation, and one that should be carefully chosen. So yeah, as I said, in my case, I use Google Cloud Function. In AWS, you might want to use Lambdas because they can easily be triggered by events. So that's the usual implementation. But of course, you can also implement this as a standalone application with sole purpose of processing these kind of messages. It doesn't need to be something that relies on cloud infrastructure. It can be your implementation. So these are some variations of how we might go about the actual auditing and triggering mapping part. So one of the simplest variants is when you're actually writing transactions, you might want to use another table to write what you're changing, basically writing the events, if you will. And this other balance mapping application would only be reading these changes and transforming them into one or multiple forms. So this is a really simple one. In this case, you could do it with SQL. You could persist these two in same transaction, and you would be pretty reliable about that. So in other case that's usually implemented, you might want to write the transaction here, but write the event directly into the queue. So that seems kind of easy, right? And mapping is easier than and all. What the problematic and unreliable part here is about doing these two in transaction. That's something that might need additional care just to be reliable enough. And the last version that I'm going to show is basically writing into the storage and then using a separate component that's just listening to these changes and producing events with it. That's basically what I mentioned with the Bezium earlier. In this case, the actual transaction service does not need to know about the need to produce events. It's just storing transactions, and this is pretty much what I implemented for this unfortunate demo. But but these elements are pretty hidden in Google Cloud implementation of Firestore triggering cloud function. Just wanted to show these free variations of how you might want to do it, because they're all fine to start with. It doesn't need to be more complex than that. With this, I would basically close this session and let you guys put some questions if you have, and I'd like to try and answer some of them.
Marko, I don't know, do you see, but we have 3 questions.
Yeah, let me just
In the Q&A part.
In the Q&A part.
Yes.
Well,
can you see them?
Yeah, I can see it. So the first question comes from Yogi Porla. I'm sorry if I read that wrong. So it says, I understand that when, say, a database is bottleneck, message queues are a way to ensure every request gets properly processed. But as you said, it will usually add latency. Is there a way that this architecture could support scaling mechanism without adding considerable latency in high-load traffic? Yeah, that's a great question. And so the latency is inherent with this design, because all of these components, basically queuing mechanism and your mapping function, writing to other storage, it takes some time. But with properly chosen technologies, it's going to be really quick. And the point is, if you scale services and storage properly, you would probably never get to a point where the actual queue is basically growing too much so that it adds latency. So as much as it's all about how much queue is actually let to grow. We actually want to probably keep it not to actually create a queue, rather create a reliability mechanism of sorts. So we want the queue just to be able to prevent loss of data, but not actually to add latency. Modern services like Kafka are incredibly fast, and probably you would not have problems with that. So once again, there is inherent latency, but if properly done, it's really small. Let me go with another question from Srđan Mitrovic. If you have a lot more reads than writes, but you're okay to see the same data, would you still recommend CQRS? It looks to me like it would be overkill over engineering to use CQRS in that case, and I would rather use some pass-through cache in that case. Does Firestore have a service for caching similar to Docs for Dynamo, or would we need to implement that ourselves to support a lot of reads for Firestore? Yeah, that again, this is a good question, and this is probably the simplest, one of the simplest ways to actually implement CQRS, although you're saying you're not doing that, because when you're actually using a cache on the reading side, that cache might be in a different form of how you persisted the data through writes. So in our case, we could, on our reading side, use caching, and it's actually the storage that we're using for caching side. It's not reliable in terms of caching service can die, and in-memory caching can die, but it's still a way of CQRS because you're reading from the cache and not from the original transaction storage. So in a way, this is the simplest way to implement CQRS, with the note that what you store in cache can be adapted specifically for what you're going to return through the query APIs. So it doesn't need to be write models, it can be read models. That's for that question. And from the third question comes from anonymous attendee. What is your opinion on CQRS with one service and one data storage? So if by one data storage we say it's one SQL instance, you would still be able to leverage some of the elements of CQRS if you use caching, as I mentioned with previous question. And you can also use persisted views on the database level to basically use them as a kind of caching, right? Because persisted views are actually a copied data. So compared to your original transaction table, persisted view of a transformation for balance is actually persisted and is updated from time to time by I mean, in SQL Server example, I know it's definitely updated directly, like a trigger kind of a mechanism. So these two options, you can either use caching or you can use some kind of a persisted caching on database level. So that's again a very simple form of CQRS because you're not reading from the same place where you're writing.
Guys and girls, please use the opportunity if you have some more questions for Marko. If not, we will try to edit this this webinar and we will put it on our YouTube page. We'll let you know and send you some email with the appropriate link. And also maybe, Marko, we can see if we can record the demo that couldn't work well and share with the share with the participants and people interested to see it.
Yeah, exactly. We'll make sure that the video on YouTube is with live demo, and so that you can actually see it in action.
And this is how we want the demo gods.
Yeah, we're gonna beat them at the end. Thank you so much, guys, for this. Once again, sorry for the parts not working, but it happens.
Thank you. Yeah, thank you everyone for the patience. And if you want to learn more about the opportunities with InterVenture, I shared some links in the chat. Thank you, Marko, for your time and for your persistence, and hope to see you soon on our next Tech Talk.
Thank you once again.
Bye.
Bye bye.